Algebra 1, Section 4.6, Part 2, Absolute Value Inequalities. It's critical that you understand the difference between and or in this chapter before we get into this. And I know I've covered this already in a previous section, but I want to cover it again. You must understand this or you will struggle with the inequality solving. That's for sure. Okay. So once again, and if you pick this up the first time, it's still worth a review. I'm just telling you this is the most important thing probably of the chapter. When I give you an interval on a number line like this, this would be the and situation. And the reason it's the and situation is because the numbers that are along this interval, and by the way, did you notice that I went by twos? 0, 2, 4, 6, 8, 10, -2, -4, -6, -10. That's fine for you to do too, but make sure your scale is consistent, right? If you put a 7 out here, I wouldn't know what that is, right? What are you going by if you go tick, 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 tick 7 from 0? All right, so have a consistent scale. And this one I went by 1, so you can see. So again, pick a number that's on this number line. Let's just choose 1 right here. The number 1 is both greater than -4, that's what this is, -4, and less than 12, right? 1 is greater than -4 and less than 12. It must be both of those things in order to be concluded in the solution set. I don't mean 1, I mean 2, right? I went by 2, so that would be 2. 1 would also be, but 1 would be here. 4 and 6 and 7.5 and 9 and 10 and 11 and 11 and 3/4 and 11 and 9/10 and 11 and 99/100 and even 12 would be on this interval. Now remember that closed circle means including, right? So 12 would be included here. And -3 would be included. But as soon as you get outside, and -4 would be included. But as soon as you get outside of that, -5. -5, while it is less than 12, it is not also greater than -4. So it's not included in this solution set. If I get out on this side, and it's 14 or 20 or 50 or a million, it's not on the solution set because though it is greater than -4, it is not also less than 12. And to be in this solution set, it has to be both greater than -4 and less than 12, or equal to, greater than or equal to -4 and also less than 12. Okay, so the way that we would write this is like this: -4 less than or equal to, let's just assume our variable is x, and then less than or equal to 12, whatever variable you like there, but it's between -4 and 12, and we write the and situation this way. Okay. Again, if you use the word and you write two simple inequalities, that's not wrong, but I don't think you're setting yourself up for success later when you do it that way. You really need to embrace this. This is the and situation. Okay, now contrast that with the or situation. Here you have -3 open circles, so that would be less than. Everything this way is less than -3. Here you have +4, and everything this way is greater than 4. Nothing, listen to me, nothing is both less than -3 and also greater than 4. If you're less than -3, you're in the negative. You're not greater than 4 also, okay? If the temperature is below -3 degrees Fahrenheit, it couldn't possibly be above 4 degrees Fahrenheit. So the only thing that could even have a solution set is the word or, not and. Because if it's one or the other, then absolutely we've got a situation where, -4 right here is less than -3. It's part of the solution set. By the way, this arrow means that it goes this way forever. And this arrow means that it goes this way forever. And if you're at 10, which would be out here somewhere, 10, while it's not less than -3, it is greater than 4, and it only has to be one or the other to be included in the solution set. So for this one, we do use the word or, and you would say x is less than -3 or x is greater than 4. You must use the word or in the or situation. You really shouldn't use the word and in the and situation. You can, but I'd rather you do this. Okay, this stands in for and. And just to kind of complete the thought, you cannot do anything like this for the or situation. You must use the word or. Okay? Now, how does that shake out with actually solving? Well, here's how I'd like you to do this. And this is slightly time consuming, but you can do it. And maybe we'll slow down. I'm way ahead of you right now with video making, so I don't know. I haven't planned this far out, but maybe we'll slow down around this section a day or so, you can really comprehend this the best that you can. Here's what I'd like you to do. 3c minus 6, which is in the absolute value, is greater than or equal to 3. I want you to think about it like this. What could go in here that would be greater than or equal to 3? Would 3 be greater than or equal to 3? Let's think about it on a number line. Here's 0. Here's 3. Really, I only need 2 numbers on a number line to understand your scale. Okay. By the way, this is not the solution number line anyway. I'm just trying to get a visual, get a mental understanding of this. Is 3, if I put 3 in here and take the absolute value of it, is it greater than or equal to 3? Yes, it is. What about 4? Yes. 5? Yes. All numbers that are greater than 3? Yes, they would be. So we're talking about things that are like this, inclusive of 3, going this way. Okay. What about 2? No. The absolute value of 2 is 2. That's not greater than 3. So 2 would not be in our solution set. Neither would 1 or 0 or -1 or -2 or any of the other numbers. I'm just using integers right now. But what about -3? When we get to -3 and I take the absolute value of it, that would be 3. 3 is greater than or equal to 3. It's equal to. So once we get here, it's like this, right? So this is the OR situation, right? It looks like this one up here, irrespective of whether the dots are filled in or not. That has something else, that's to do with something else, right? The OR equal to. The way these arrows are pointing is like the OR situation, okay? Now with that in mind then, this really doesn't need to be part of your work. You can. I think it's good, but just to save myself some space, I'm going to get rid of it. And here's the thing. Either 3c minus 6 is greater than or equal to 3, like you saw on the right part of that number line, or 3c minus 6 is less than or equal to -3, like you saw on the left part of that number line. Okay? And then we'll just solve this like you learned earlier in the chapter. Add 6 to both sides. Divide by 3. 9 divided by 3 is 3. By the way, if you divide it by a negative or you multiply by a negative, you still need to switch the sign. But we didn't here. Over here, add 6. Divide by 3. And here's your solution. C is greater than or equal to 3, or C is less than or equal to 1. Now on a number line, and we already know how to do this, but just real quick. Here's 0, 1, 2, 3, 4, 5. Greater than or equal to 3 would be like this. Less than or equal to 1, like this. The OR situation. Again, that it has the same quality as the number line that I did to kind of just help you conceptualize this. But obviously the points are in different locations because we weren't graphing the solution set from the start. We're graphing it now that we have the solution. Okay? Now, let's contrast that with this problem. 2n plus 3 is less than or equal to 5. Ask yourself, what, when I take the absolute value of it, would be equal to 5? Okay? Could I put 5 in? Yes. Could I put 6 in? No. So again, on a number line, where here's 0, here's 5, here's -5, when I plug in 5, it works. When I plug in 6, it does not work, so nothing this way is going to work. But what about 4, 3, 2, 1, 0? All those would work. 0, its absolute value is 0, and it is less than or equal to 5. -1 would work, because -1's absolute value is 1. That's less than or equal to 5. -2 would work, -3, -4, -5. All these would work. In fact, this is the interval situation, or what I'm referring to as the AND situation. Okay? When it's an interval, it's AND. When they're going away from each other like this, it's OR. This is an AND situation. Now, again, understand what this is then saying. What's in here, which I have question mark here, which actually is 2n plus 3, has to be on this interval, greater than or equal to -5, and also, greater than or equal to -5, and also less than or equal to 5. Now, here's what that actually looks like. What's in the absolute value? The 2n plus 3. It's less than or equal to 5. It's also greater than or equal to -5. Write it just like this. Okay. If you want a rule for that, just write it just like it is in the AND situation. Once you determine it's AND, not OR, just write it just like it is without the absolute value, and then take this symbol right here and repeat it right there so that they're both pointing the same direction. And then take this number put it over here and make it negative. Okay, that's really the mechanics of it. That's not exactly the conceptual nature of the way I taught it to you just a minute ago, but those are the mechanics of it. And then what I taught you earlier in a section was you need to subtract 3 in 3 places here. This is -8. This is 2n. This is 2. So then you're going to divide both all 3 parts by 2, in which case you're going to have -4 less than or equal to n less than or equal to 1. This is your solution. This is the and situation. And again, on a number line then, where that is here's 0, here's 1, here's -4. Again, at least 2 numbers with a consistent scale would work for me. And here's your interval. Okay? And what I'm saying now is with this solution in that interval, pick any number along this interval. It'll make this inequality true when you plug it in for n. Pick anything outside or anything this way, it'll make it not true. Okay? Let's quickly finish up here. Here you need to subtract 2 from both sides first. So this would be the absolute value of 3.5z is greater than or equal to 7. Okay, and again, ask yourself what could go in there that would be greater than 7, right? And that would be numbers that are bigger than 7 or less than -7. Here's 0, here's 7, here's -7. If I put the number 7 in here, that actually isn't greater than 7. It would be greater than or equal to, but this doesn't have or equal to. So 7 is not going to be there, but anything above it will be there. 8 is greater than 7. 9 is greater than 7. I'm talking about numbers that I plug in here and then take the absolute value of it. -8, -9, -10, and for that matter, go smaller, but closer to -7. -7.5, -7.25, -7.1. All of those would work because -7.1, take the absolute value of it, it's 7.1. 7.1 is greater than 7. So we're looking at this. I hope this is making sense. Okay? So this is the OR situation, backing up now and considering the OR situation. I realize this video is getting long, but this is intense stuff, so I hope you're sticking with me here. 3.5z is greater than 7, or I should move that over a little bit. Or 3.5z is less than -7. And here you would simply divide by 3.5. That's z is greater than or equal to 2. Again, that was a positive number we divided by, so you did not have to switch your sign. Here, divide by 3.5. Z is less than -2. Use the word or in your final answer, and I'm sure you know how to graph that, so I'm going to move on to the last problem. Here, the first thing I would do is switch these things around. Absolute value of 6 plus 3t is less than or equal to 9, right? That looks identical to the last time I did a inequality sign and did it a little carelessly. I would switch things around, and did you notice that greater than became less than? If I move this to the left and this to the right, then the sense of the inequality switches. I just like the absolute value to be on the left, so I'm doing kind of the same thing every time. You do what you want, but don't get it wrong, right? All right, so one more time. What could go in here and be less than 9? 8, 7, 6, 5, 4, 3, 2, 1, 0 would all be less than 9 when you take the absolute value of -1, -2, -3, all the way up to -8 and up to, but not including, -9, right? So from -9 to 9, not including those two endpoints because it's less than, not less than or equal to, we have a solution set, or what I have been calling an interval. Here's 0, 9, and -9. We're talking about this, okay? So that's the and situation. Again, just saving myself a little space here, and you could do the same or do the little arrow thing on the margins to help yourself. 6 plus 3t is less than 9. It's also greater than -9 when I read that from right to left. Again, mechanically, what did you do? You just kept the less than, put it over here, took this number, made it negative, and put it over here. Okay? Then subtract 6 from both sides. Not both sides, all three places. Let me show it. Subtracting 6 here, and here, and here. You get negative 15. You get 3t is all that's left here. You get 3. Then dividing by 3, you got negative 5 less than t less than 1. Okay, so it didn't come up, but just in case, if you do divide by a negative in any of these where we did have to divide, they ended up being positive numbers. If I were dividing by negative 3 here, yes, I would switch the less than symbols around to be greater than symbols. Okay, thanks for sticking with me on this longer video. Good luck.